Hey everybody, what's going on? Welcome back to Data Points. Today we're going to be talking a little bit about using NLP, which is natural language processing, to try to predict fake news. Now this is obviously something that has come to the fore more recently than in the past, but I venture to speculate that fake news has been something in and around the world pretty much forever. There's that famous quote that a lie can make it around the world before the truth has time to put its pants on. So that has always been the case, and it will probably always be the case. So the real question is can we utilize new technology, data science modeling, different things like that, to try to predict whether or not an article is fake news or real news before or after it starts to get, say, spread on social media, and it can be shut down if it's something that is misinformation, something that is not true. Can that be done? And this is something that social networks have had trouble with most recently, Facebook being the big one, when it comes to this idea of fake news. And they talk about how difficult it is to isolate, to find, and all of those kinds of things. Now, obviously, they have human curators at Facebook. They have them to be able to look over the shoulder of things like AI and modeling and things like that to see if it's doing exactly what they want it to be doing. But that is obviously not scalable. So can they utilize these models to do that? Today we're going to talk about a very simple project. I'll walk you through the entire Jupyter Notebook of how we took two data sets and basically we were able to come up with a pretty accurate model for predicting whether or not the article was fake or not. Now, there is a problem there, right? Because obviously this works and I'm about to show it to you. So why is it so hard for these companies to do this work? Well, one, as the authors of some of these things figure out the tips and tricks and ways to be able to get past some of these models, that's one issue that's going to come about. As the model continues to learn, it will get smarter, but so do people, and so do the models that they've created to be able to create these, and it just kind of becomes a model against a model, right? But that's one of the issues. The other issue is scalability. These are enormous companies that get a ton of data each and every single second, let alone minute, let alone day, hour, day, week. It's crazy, right? It's really something that can boggle the mind. So though what we're about to review is a workable model, it has a decent bit of accuracy, it can also have its own issues and things like that, but also this idea of scalability can cause an issue. So be thinking about that as we work through this Jupyter Notebook and as I kind of walk you through what it is we're looking at. First things first, this was a project for a lunch and learn for the school I learned data science at called Code Up. So some of the things that we'll be talking about here are going to be more relevant for a future video, but just wanted to kind of give you a heads up there. First things first, this is going to be the Jupyter Notebook. It will be up on GitHub. I'll have a link down below for you guys to go check that out. These are some of the imports that I brought in prior to kind of starting this project. We have our typical kind of base level imports up top, NumPy, Pandas, OS, those types of things. After that, I brought in some visualization libraries, Seaborn, Matplotlib, image from the PIL library, and then of course everyone's favorite NLP graphic word clouds. We'll talk more about that here in the future. From there, we have our NLP libraries. NLTK is obviously the big one. Then we have stuff coming in from sklearn. We've got Beautiful Soup coming in. From there, we've got some additional sklearn metrics, model stuff. We've got a train test split obviously kind of coming into play. And then we have some deep learning coming in with Keras, TensorFlow. Now, I didn't end up using all of these libraries. These were just ones that I brought in because I wanted to have them available when I was starting it. So we'll walk through the ones that we did use, some of the ones we didn't use. Now, obviously, this is something where you could either import as you go, you could go back up and clean up what imports you didn't use. I just wanted to have these listed up here just so you can kind of see where my starting point was prior to really getting into the project. From here, we bring in our data. We have a true and a fake CSV data set. Looking at the dot head here for both of them, they both have titles. They've got text for their articles themselves. They've got a subject, which is, I'm guessing, some sort of, whether it's political or sports or something like that. And then they have a date from when the article kind of came out. One quick thing to note, and this is when I'm talking about models learning how to beat the system, as it were, maybe next time around. For the actual articles, you can see that at the top of each one of these texts, when they were pulled, there's like Washington Post, Reuters, Washington, Reuters. there's actual news outlets being referenced right at the top of the text, whereas it would look like here in the dot head here for the fake articles, that isn't quite the case. So this is something that they could potentially change in the future. It might be a situation where you have to, they have an all capitalized location and then they've got a parentheses official sounding, outlet or something like that. Those are the things that they can start to learn and utilize to take away maybe some of the accuracy and power away from a model that you've developed. Just things to kind of keep in mind. If we look at the shape here of each of the data frames here, true and fake, they're relatively the same size, pretty good data set here in terms of balance. I've added a category to each data frame called 1 and 0. You'll see why here in a second. 1 being true, 0 being fake, false. Because when we concatenate the true and fake data frames together into one data frame, we want to be able to have that category over here as a means of reference whether or not this was a fake or real article, right? So you can actually see here, this is a df.sample, a little bit different than a head, but it still gives you an idea of what you're looking at. So you can see here in all the official actual articles, almost none of them have a ton of capitalization right off the top. Over here, you can see a ton of capitalization right off the top in some of these titles for the fake news articles. Again, you can kind of see really easily here, you've got where the story is taking place, and then the outlet, nothing. Where the story is taking place, the outlet, nothing. Where the story, you can kind of see a pattern there. That's something that your model is going to be pretty capable of picking up on when you set it up. So again, this might be something that they utilize in the future to get beaten out. So let's do a little bit of EDA. Let's explore this data just a little bit before we get into the modeling. First things first, let's just look at a basic count of how many fake to real articles we have. Like I said before, fairly balanced here in terms of the data sets. Moving on from there, there are no nulls in this data set that we have here in these two data sets that we combined here in this data frame. We can see that here, obviously, with the isInA.sum, and then of course, if we're looking at .info, we can see that as well. So we've kind of got it broken out here, right? From all the above exploration, we can see that it's a fairly balanced data set, no null values. We have a total of 44,898 observations to work with moving forward. So as we continue down the exploration before the modeling, I kind of look to ask myself some questions, and I'm thinking about what I'm seeing in the data and all of those things. So again, we talked about that subject before. So I was wondering what subjects are covered in this data set? What do we have here? So we've got a breakout here of how many different subjects. We just do a dot value counts. These are the counts per subject per this entire data frame here. And though this isn't it isn't balanced in the general sense, it does give me an idea of what we're talking about, what's happening with regards to the category. Now, the very next thing that led me to, when I put, interesting here, was what was the breakout of categories by fake to real news? So we did that. We set it by hue of category, and sure enough, we've got a pretty even split here. There are no categories in the real news that are politics news with capitalized, and no categories in the real news that are world news, and vice versa, right? So we can clearly see here that if we left this information or somehow included this information in our modeling, it would very quickly pick up on this and go, oh, look, here's something that is a part of, something that we'd be able to utilize. So we're probably going to have to drop that from any sort of analysis moving forward. From there, we're going to create the corpus, which will be the entire text that we'll be running through this NLP model. For that, we'll be having the title plus a space plus the entire text field of the article itself. We'll also be deleting the title and subject. We'll be deleting the title because we'll be including it back into the text. The subject we've obviously just discussed is something that we're not going to be able to utilize. And then the date. Though this is an interesting thing that we could possibly look to include or somehow continue to use within our analysis, it isn't something that's really pertinent to us right now. Again, this is just a really brief, kind of simple NLP project for the purpose of another project, which I'll talk about more in the future. Let's see, now we need to clean up the corpus. So from here, we're going to create a couple of functions utilizing beautiful soup and just some basic regex. We're going to be getting rid of some brackets, some of the bracket notation, some of the links that might exist within the corpus itself. We're removing stop words. Those are going to be actually, I've discussed NLP in a future, or in a past article, in a future article. I'll probably discuss NLP a lot. I love it. But I actually discussed NLP utilizing an Amazon reviews data frame. So I'll be sure to link that article up down below because it goes into a little more detail on some of this other items here. But suffice to say, this just allows us to clean up that corpus, allows us to clean up that full text that we have for our analyzation. So now, obviously, we have our beautiful word clouds. In case you can't tell, I have a love-hate relationship with word clouds. This is something that a lot of people like to use. This is our these are our real news articles. The most frequently used words here are larger than the other words. And this is our fake news articles. So clearly you can see Hillary Clinton is an enormous word here. It makes a brief mention over here on the word cloud for true. Yeah, they're decent, fun, but I don't really love this look. I prefer to customize my my word clouds. So utilizing this code here, which you can find on GitHub, this is a word cloud for your real news, and this is a word cloud for your fake news. So pretty interesting, just something to check out. Definitely take a look at that. You can totally steal that. I can do another video or article on how to make these a little bit more in depth if you'd like. Real quick note, if you comment out, or uncomment out, I should say, this code right here, it will export a very high quality version of this image here. I'll show those up on the screen right now. Just a really, really cool tool. I've utilized it in the past for a variety of different word clouds. And you can use an image, you can use letters. It really doesn't matter. It's a pretty neat thing to utilize. From here, we're going to finish up our EDA, just again looking at a couple of different things. How many characters are in each article? Is there anything that we can really pull out of that information? And here we're going to look at the words per text. Again, is there anything we can pull out? And, by my estimation, there's definitely some breaking points here. These are looking like not as varied in terms of its text count and character count. But again, it's not so different that I think it's something that we should be concerned with, or something that's really going to be a huge flag for me to kind of see or notice. From here, we're going to break out our data frame into a train test split. We are going to stratify to make sure we have a good split of data in both the train and the test. We'll set a random state for each of those as well. The first thing we're going to do is we're going to use a count vectorizer, a bag of words, as it were. And then the next we're going to do is a TF-IDF. Again, the article I talked about before that will be linked up goes into a bit of more explanation of these. If you want, we can dive even deeper next time on NLP on those two items. From here, we just kind of set our model up, run it through our train and our test, and we are left with these results. We have a 94% accuracy on the count vectorizer and a 92% accuracy on the TF-IDF predictions for our test sets for this. So relatively decent. We're left with a pretty good understanding of this. I've got it commented here. At the end of some quick EDA and NLP modeling, we're left with a high level of understanding of the two data sets, some charts and word clouds for a data product, and a model that currently has a 94% accuracy for the bag of words count vectorizer and 92 on the TF-IDF. Now, as you can see, we're left with some decent results. We could have brought in some deep learning. We could have utilized a new, I don't want to say new, I don't know exactly how new it is, but there's a really cool NLP library, I think is what you would call it. It's called Glove, Glove. I'm really, really looking forward to trying that out. I could have brought that in and probably bumped up the accuracy of our model. What I really wanted to do was create a quick video regarding a data project that I was working on, and you can see we've done all of that, which is fabulous. NLP is one of my favorite things within the data science and data community. I love it. I think it's an incredible tool that we can utilize across numerous different applications. So I'm a big fan of it. Here, the question that this posed to me, and the thing I wanted to look at was, as just one person looking at a data set, they're decently sized, almost 50,000 observations. Could we produce something that was usable, something that was acceptable in terms of accuracy? And we were able to do that. So it makes me wonder regarding some of these social networks and other places where they have issues with things like these fake news. What are they looking at? What are the struggles that they're seeing that is making it difficult for them to tackle some of these issues? I would venture to speculate that the data science team at Facebook is, and I know it is, but is world class, right? So what is it they're seeing? Is it a scalability issue? Is it the way that they're able to scrape from the sites that are then sharing this information? How difficult is it to scrape a Facebook post someone's making where they're just edit, copy, edit, pasting maybe one of these articles? All of this stuff creates tremendous problems, but I think NLP might be a way to solve it, among numerous other things. Anyway, thank you guys so much for checking out today's video. We'll catch you in the next one.